Okay, cool. Yeah, so I've got a YOLO model trained on a bunch of different circuits and circuit elements, and it's able to recognize about 30 different classes. So I used Ultralytics YOLO V8, which is a model that's typically used for real time like object classification and image recognition. So think like self-driving cars or stuff like that. And it's known for being very, very fast, very, very low latency. But I'm just using it on still images, and I found that it's still pretty accurate, works pretty well, and it is very fast. And so I'm just gonna go to my project here, um, and just run a quick example. So we're gonna run it on this circuit image right here. This is a pretty good image. It's a pretty well defined lines, classes, different components are spaced nice and far apart. So I expect it to do pretty well on this one. And then I've also got another image right here. Still a good quality image, very defined lines, but I don't think it's going to do as well. This is a very confusing mess of lines right here. I think they'll still get some of these classes, but I don't have high hopes. So yeah, we'll see how it does on these two. I'll just get these out of the way. And so I'm just going to run the script that kind of does my little workflow on it. And here we go. And bang. So we can see this is our first image right here, test 7. And looks like it got pretty much every single class instance. And so we can see we've got each class name and then also the confidence above it. And then I've also got lines connecting each class. And these lines are actually very, very important. This is how I determine what's connected with what, how things are related. And these took a while to get right. I'm just using OpenCV's LSD line segment detection function or algorithm, and it detects all these. It's detecting all these lines, everything. And so I had to add a bunch of logic, like thinking about how close lines should be when they merge, how parallel do they have to be, how perpendicular. A line has to be touching at least two components to be considered a valid line. I have to clear all the lines that are inside a bounding box. And so, yeah, but got it working. Looks like most of these lines are good. And despite all that, we still have some noise over here, this junk line right here. But that is what it is. That's what happens when you use models like this. Then we can actually try on the, oh yeah, before we do, we can see that this took 1.01 seconds. This is actually really slow. I think a lot of that time comes from my computer just having to like go display that image for me. But in this project's actual use case, where it's the backend for a circuit editing website, where you can just upload a photo and then get the components in that photo right in your editor, it's going to be a lot faster, well under a second through the API. So we can actually, let's get this command ready, and then we can try test 8 here and see how this goes. And yeah, kind of as I was saying, still does okay. Still gets a lot of classes, pretty confident. But it does not do well with this mess of lines over here. And this is just because of how I've defined what a valid line is. The raw LSD algorithm from OpenCV will detect these. It does, but um, right now my logic isn't at the point where it can consider these lines or not, because it's not identifying any junctions here for the lines to connect to. So yeah, we X this out. We can also see the stats from that run too, and we actually got it under a second that time, so a lot better. And then we can see we start with 330 raw lines, 387 for each of these, and then we're able to narrow it down to much less lines. And then I can actually show the um, how this would kind of look on my website. So I'll just start kind of a development server for the backend right here, just get that going, and then I'll also start a development server for on my front end right here. We just do that, and that should be ready at localhost, and here we go. And so you can see this is the circuit editing website. We can place down components, get stuff all drawn out and ready to go. It's got some pretty cool features like snapping to wire, wires automatically kind of merge together. You can see that. They also snap on component endpoints to make nodes. So very cool. But that's not the point. The point is to see how this object detection works. And I'm going to use a very simple example here. I'm going to use test 3, which is just kind of 4 inductors in series with a crossover in the middle. So we'll upload that, run the detection, and bang, it actually does give us the components. The wires are missing though, and that is as expected. I haven't added the logic quite yet to draw some wires to connect components. That's the next step. But these components are organized very logically. I think it's 50 pixels, and then just increments of 50 between them. And I also do have a lot of code that tries to determine the orientation of a component. And as you can see, it did a pretty good job here. It got these at 90 degrees and this at 0 degrees. Um, and we are missing an inductor here, and I think this is because my YOLO model just did not identify this class. And we can actually double check that if we just run the algorithm on test 3 and do it. And yeah, we can see right here it actually thinks this is text. And when I'm sending stuff over via API to my website to display, I'm not sending the text over. And so this inductor just gets left out. But we can see they'll actually did a pretty good job on the rest of this. It gets all of this, it gets all the wires. And so just kind of refining the code, definitely adding that wire logic in at the next step. But yeah,